All right, let's dive in. Today, we're cracking the code on a challenge that's basically a rite of passage for any programmer out there, the legendary Fizz Buzz. It seems so simple on the surface, but there's a really clever little trick to it. So let's get into it.
So, what's the big deal with this puzzle anyway? I mean, really, it's just a counting game. But in the world of tech interviews, it's a famous gatekeeper. It's not really about what you know, it's about how you think. It's built to see if you can take a few simple rules and turn them into clean, logical code.
So here's how we're going to deconstruct this thing. We're going to start with the rules of the game, then build the logic from the ground up, and finally, we'll translate that logic straight into code. By the end of this, you won't just know the solution, you'll actually get the elegant thinking behind it.
Okay, before we even think about writing a single line of code, let's just understand the game. Don't worry about loops or variables or any of that stuff yet. Just pretend you've been handed a set of instructions for a game. Our only job right now is to understand those rules perfectly.
Here's the mission, plain and simple. You get a number, let's say it's 15. Your job is to make a list that counts all the way from 1 to 15. But here's the twist. You have to swap out some of those numbers with specific words, and it all depends on a few rules. Let's take a look at what they are.
And here they are, the rules. They're actually super simple, only 4 of them. If a number can be divided by both 3 and 5, you write FizzBuzz. If it's only divisible by 3, you write Fizz. If it's only divisible by 5, you write Buzz. And if none of that is true, you just stick with the number itself. That's it. Simple, right? But the real magic is in the order you check them.
Okay, we've got our rules. Now for the fun part, actually solving the puzzle. This is where we stop just reading instructions and start building, a logical machine. We need a sequence of checks that's going to give us the right answer for any number every single time.
And this right here, this brings us to the absolute heart of the FizzBuzz challenge. Just look at those 4 rules again. Which one do you think has to come first? This one decision, it's the difference between code that works and code that's full of bugs. It is the key that unlocks the whole thing.
So here's the trick. You have to check for the most specific condition first. That's FizzBuzz. Think about the number 15 for a second. It's divisible by 3, and it's divisible by 5. If your first question was, is it divisible by 3, you just say fizz and stop, and that's wrong. By checking for the combined FizzBuzz case first, you catch those special cases before you move on to the more general ones.
Now that we've figured out the logic, the rest is really just translation. We've built the blueprint. Now we just have to teach the computer how to read it. Let's see how our logical steps actually look in a real programming language.
So our first logical check was for numbers divisible by both 3 and 5. In code, that's just an if statement. And here's a neat little trick. We can just check if it's divisible by 15. Why? Well, because any number that's divisible by both 3 and 5 has to be divisible by 15. So this one line of code takes care of our most important rule. Okay, so what if the number isn't divisible by 15? Well, our logic says the next step is to ask, is it divisible by 3? In code, we use something called an else-if statement. That little % sign you see there is called the modulo operator. All it does is give you the remainder after you divide. So I%3 = 0 is just a coder's way of asking, does this number divide perfectly by 3? And we just keep going right down our logical path. If the number isn't divisible by 15 and it's not divisible by 3, our next else-if checks if it's divisible by 5. See how clean that is? It's like a waterfall of decisions, one after the other, exactly like we planned.
Finally, we need a catch-all. What about numbers like 1 or 2 or 7 that don't meet any of our fizz or buzz conditions? That's what the else block is for. If a number gets through all of our other checks untouched, this final step just adds the number itself right to our list.
All right, moment of truth. We've defined the rules, we've built the logic, and we've written the code. Now, let's put it all together and actually see our creation in action.
We're going to use the classic test case, n = 15. And this is the perfect number because it's going to make our code use every single rule that we just created. And there it is. Just look at that output. It's perfect. The number 3 becomes fizz. The number 5 becomes buzz. And most importantly, 15 correctly becomes FizzBuzz. All because our logic checked for that special case first. Our little logic machine works.
So as you can see, cracking FizzBuzz was never really about memorizing lines of code. It was about one thing, being able to create a clear, ordered, logical process that starts with the most specific rule and works its way down. It's about bringing order to a little bit of chaos. Ultimately, the lesson from FizzBuzz goes way beyond coding. It's about taking a messy set of requirements and finding the simplest, most logical path through them. So, I'll just leave you with this question. What problem, maybe in your work or just in your life, could you solve today by taking a step back and thinking, okay, what's the most specific condition I need to check for first? Thanks for watching.